Hello everyone, this is Olga Media. As you know, we support technology, culture, and people. And one of the famous persons, speaker at Embedded System Conference here, Bob Zeidman. Hello, how are you?
Hi Olga, good to see you.
You have great experience and education. Would you please share with our public?
Sure, so I have a couple of degrees from Cornell University. I have a degree from Stanford University. And I worked for a few years in Silicon Valley at a semiconductor company, a computer company, a supercomputer company. And eventually I decided to go off on my own and do consulting and develop hardware and software for various companies, companies like Cisco, Ricoh. These are some of the bigger companies, and then smaller companies also. And along the way, I became an expert in Verilog and FPGAs, field programmable gate arrays, and ASICs, application-specific integrated circuits. And so I wrote some papers, and then been invited to speak at different conferences. I've been speaking on and off at the Embedded Systems Conference for about 15 to 20 years. And it's always an honor to be here. That's where we are right now. Then eventually I wrote some books on the topics, again, Verilog, FPGAs, ASICs, things like that. And I have a book, Just Enough Electronics. Sorry, the book's title is Just Enough Electronics to Impress Your Friends and Colleagues.
Okay.
For people who are in marketing and sales or just want to impress engineers with how much they know. It's everything that you need to know about electronics in one very easy to read book.
I like how you said like a couple of degrees from Cornell University, one degree from Stanford. Would you please kind of give me details?
Oh, sure. So at Cornell, I got a bachelor's degree in electrical engineering and a bachelor's degree in physics. If you want to know the story,
yes.
I was originally a physics major, and I decided that I wanted to know about electronics, that would be my hobby, that it was fun to do electronics. So I took an electronics course that was everything in electronics for physicists. And it was the hardest course I ever took. And I didn't do as well as I thought I should have. And instead of giving up, I decided I'm going to learn electronics. So I started taking electrical engineering classes, and I did very, very well. The first class, I didn't do that great, but every class after that I did really well. And after a while, I realized that I had enough classes to get a degree from the engineering school, so I took the degree. And then I went to Stanford, and at Stanford, I really wanted to be a physicist, but I realized there were a lot more jobs in electrical engineering. And physics was hard, although I love it. I loved it then, I love it now. Physics is really hard, whereas I found electrical engineering to be fairly easy. At first I thought if it's easy, it can't be a career. It could be a hobby. But after a while I realized, I could have a career that's also fun. And I don't want to say easy, it just came very naturally to me. You know, right. I have to put a lot of time into it, but I love putting in the time. It's just fun. And the difference between physics and electrical engineering is that in electrical engineering, when you solve a problem, you build it and it works. In physics, you solve a problem, you write it down, you publish it, and that's the end of it.
So you like to put more hands-on?
Yeah, it's something to show my mom, my friends, look at this thing I built.
Now, in terms of your company, you're founder of the company.
Yes, so I'm the founder of Zeidman Technologies. One thing I didn't mention is that I've actually been writing software since I was 13 years old.
Okay.
In junior high in Philadelphia, I went to a school. At the time, it was very rare for a school, especially a middle school, to have a computer. But we had our own computer, and we had a connection to a computer, and I became fascinated with it. And I actually wrote an operating system when I was in high school, and I won a national award for it. And when I went to college,
Which year it was?
Oh, that was 1977.
Okay.
Okay. And when I went to college in 1977, the second half, I decided I didn't need to study computer science or programming because I knew everything I ever wanted to know about programming. So I actually went through 6 years of college without, I think I took 1 or 2 computer classes because I needed the credits, but I never intended to do anything with it. But as I got into the real world doing electrical engineering, I found that ideally I needed to know software. And so I started developing more software to go with my hardware, and that leads me to my company, Zeidman Technologies, because when I went off on my own doing consulting, I was originally designing computer chips. Then later people asked me to design computer systems.
Okay.
And when you're designing computer systems, you need to have firmware, so the software that's running
Right.
on the machine. And I found that I could do that as well as anybody else, so why not do that myself also? And that led me to a contract at Apple, which writing firmware and getting frustrated by some of the development going on. And that's when my contract ended, I thought, how can I improve this process so that it goes a lot faster?
So then you created some software tools for it?
Right, right. So at Apple, I was at Apple at a time when people didn't want to be at Apple. It was right before Steve Jobs came back. And in fact, he came back when I was there. But at the time, there was the internet boom, and people wanted to work for, pets.com and, some of the, Alta Vista. Some of the companies did well, a lot of them didn't. But obviously, companies like Amazon did well. But people didn't want to work at Apple. And we were creating the firmware for the flat panel display. So the Apple came up with a studio display, if you remember that. It's just the first flat panel LCD display. And what people may not know is that there's processors in there, little tiny microprocessors running code that we'll call firmware that controls how does it take the video in. If the user presses a button, this processor has firmware that says, oh, that's the contrast button, I need to lower the contrast or increase the brightness,
Right.
or put a display up. And so there's really a little tiny computer system inside there. And I was writing a code for that, and we had some people at Apple. We had some people who were very good, and some people who would make mistakes, and we would spend a lot of time figuring out the mistakes. It could be that you're watching a video on the display, and you press a button, and then all of a sudden it goes black.
Okay, or too bright.
Right, right. And then you can't fix it. It just doesn't do anything anymore.
Now we know who to blame.
Right.
Engineers who didn't pay attention, I guess.
That's exactly what happened. And I would get frustrated because I would debug these problems, and I thought, these are very low-level problems. Why are engineers still writing code for these low-level things? Why can't we have a tool that handles this automatically? So I created our SynthOS tool, which creates a custom real-time operating system.
Okay.
And what that means is, if in the flat panel display, for example, if you were to use our tool, synthos, instead of worrying about how does this task communicate with that task, how do I schedule this one? If the user presses a button, how do I stop whatever's going on and handle that button press? Instead, you just tell a programmer, essentially, write a routine that tests whether somebody's pressed a button. Okay, write another routine that controls the contrast. Write another routine that takes the video input. You write all these routines, and they're just very small routines. And then our tool, you run it through our tool synthos,
Okay.
and our tool creates the code to manage all these routines so that nobody else has to do that.
So now, in terms of the software tool you created, it's very easy to use?
Yeah, we say create a real-time operating system at the push of a button. And, if you were to do the traditional way of doing this, you would you decide on what hardware you want, what microprocessor you
Right.
want. You get a real-time operating system that goes on top of it.
Right.
And some of these have manuals that are hundreds of pages long that you have to understand.
Right.
And then you say, let me create my software to work with this operating system on this hardware. If you use our system, we have a manual that's 19 pages. In a seminar earlier today, I taught people how to use it in 5 minutes.
Okay.
And now what you do is you don't start with the hardware, you don't start with the operating system, you start with all the tasks that the thing needs to do. Push a button, change the contrast, get the video. Then you run our tool to create the operating system. And once you've got that, you can run it on any platform, any hardware that you want. So you start with the easy stuff, and the other stuff is done automatically.
Great. So that's people will find out the information on your website page?
Yes. We actually have two websites. One is Zeidman.biz. It's Z-E-I, remember E before I.
Yes.
Zeidman.biz. And we also have synthosonline.com, where you can actually use the tool online completely for free.
For how long?
We don't have any plans to take it down. We want people to use it, to test it. They can come up to speed very quickly. The idea is we want the community contributing ideas, contributing code, using it, giving us feedback, and perfecting it. If you're a corporation, you probably don't want to use it online because you don't want your code to go over the internet. So instead, if you're a corporation, you would set up the tool inside your offices, and then you have to pay for it.
Great. So what would you like to wish our audience then? They know where to find, because they can try your tools for free and unlimited.
Right. And again, we have no plans to change that at this time. It's free. What we'd really like is we'd like people to try out the tool, see how well it works, see how quickly you can get a system up and running, and give us your honest feedback. We want, we're a small company. We really want this feedback to understand what features do we need to add, how well is it working, and have the community contribute to the product.
So, Bob, tell us about the future of software development.
So that's a good question. The way I see it and the way my company sees it is right now, software depends on hardware. So the hardware is developed first, and then when software is developed, it depends on the hardware. And specifically in embedded systems and Internet of Things systems, the hardware is decided on first. Then there's a real-time operating system on top of that. And then the applications have to conform to the real-time operating system that have to work on the hardware. We're trying to reverse that. We want software development to all start with software. We want people to write applications that do things. In the example of the flat panel display I mentioned, we want people to write, here's a task that controls the buttons. Here's a task that controls the contrast. Here's a task that controls the video input. And then from that, they run our SynthOS tool, and that creates a real-time operating system that works on any hardware platform. In fact, in the future, we plan to have tools that will tell you which hardware platforms will meet your requirements, your cost requirements, your power requirements, things like that. So we want to turn software development upside down. Instead of the hardware determining the software, we want the software to determine the hardware.
So in terms of building the bridge, before we build the bridge, now we can run software and all the measurements, and then we can build the bridge.
Exactly.
Maybe even print it in 3D just to be sure.
Yeah, that'd be terrific. We'll add that to our list of tools.
Because then if we space the shuttles into the space, they would not be damaged and all those billions of dollars lost or anything else like that, because we don't want to waste our time. So.
Right, and this, people want their software to function correctly. And our whole idea is to get it to function correctly, then figure out what the hardware should be. Just get it functioning correctly first.
Great. And in terms of Internet of Things, what's happening there? It's another buzzword around Silicon Valley and the entire world. So what can you say to us about that?
Well, our tools, and I'm glad you mentioned that, because our tools are very well suited for the Internet of Things. And that's why we're seeing a lot of interest suddenly. Because if you're putting a real-time operating system, an embedded system into a high-end device like a large screen TV or a network router that might cost thousands of dollars, well, then you can afford to have a more expensive processor, more expensive hardware, more memory. That memory costs, has a cost to it. You can use up more power.
Right.
But if you're putting processors and intelligence into little tiny devices like light bulbs,
Right.
then you don't want to have a big processor, a lot of memory. You don't want to use up a lot of power. You want something that's small, fast, low power, and cheap. And that's where our tool is perfect, because it creates something that's really tiny, works very fast, and requires very small, low power, low cost hardware. So for Internet of Things, we have an ideal solution.
Now, you are here at the Embedded System Conference, probably not first time.
No, I've been coming on and off for about 15, maybe 20 years now.
So why we need to have those conferences and see people? What's your opinion on that?
Well, I enjoy it. I especially like giving lectures. I like educating people. I like teaching people how to do things better. It's also a benefit if it helps me sell products, but I've been doing it for years just because I enjoy teaching people. And it's good to network and meet other people, make business contacts, for not only for doing business deals, but also just for learning from people who have different ways of doing things that I don't think about.
And they have tiny little devices which get smaller and smaller in the last 15 years and gets more sophisticated and prettier. I must say, fascinating in the way, and make pretty much all devices getting smaller and smarter.
Yeah, it's always fun to come here year after year and see the amazing things that people are doing with the technology. And it's sometimes frustrating to me because I see these great things and then I spend a lot of time thinking, how did they do that? How did they fit all that intelligence into that little tiny device?
And of course, I know that your company also offering free tool and devices to not only attendees of ESC conference, but everyone. What is that?
Right. So if you want information about our company and the tool, you would go to Zeidman.biz. It's Z and then EI. Remember, E before I.
Right.
Zeidman.biz. But if you want a free, perfectly 100% free, fully functional version of our software, you would go to synthosonline.com. And there you can upload your code, do the synthesis, create the operating system, and then download the resulting code. Completely for free, fully functional. We want the community to contribute. We want them to use it, to see how valuable the tool is, how useful it is. We want them to contribute code and tips and feedback on how to make it better. So it's all out there for them to use.
Great. And of course, for our last questions, I guess your wish to our audience.
Well, I wish that they have much success with their endeavors. I hope that they use our tool, our SynthOS tool, to create their products, and that it makes it more efficient, lower cost, and helps them be successful. If they are a company that does not want to use the free tool because that requires uploading their code to our site, then they can purchase a tool for internal use, and we'd be glad to help them develop code for it.
And of course, I would like to say thank you to Embedded System Conference, UBM marketing team, and also Antenna Company who made this meeting finally possible, and
Yes.
learn about you as a great person, great educator, and book writer. So please keep it up and let us know what's going on.
Okay, thank you. And
Thank
thank you
you.
to you, Olga, for having me on your show.
Thank you. Goodbye.